Hello everyone, thank you for being here. First of all, I want to make it very clear that I'm very poor at public speaking, so bear with me. um, so, I want to start with what happened recently. I was trying to teach React to a friend of mine. He's a developer. He has been working with Django and PHP and old school web development for some time. And he came to me for advice and asked me, he was confused about how React fit into his mental model of how the web worked. He thought that the way web and web applications worked in the past, I guess, not very past, but still, was that every request generated a new web page, basically. And each of those web pages contained JavaScript scripts. And he thought that React would work the same way. React would be included in every page, and all of the components would be made with that. And he was concerned that why do we need React for that? Because we could already do that with PHP. We could just make DOM elements with PHP itself. Why do we need that just to change some text with some state? That just seemed very inefficient. So this was not a new problem for me. I'd actually faced the same issue when I was trying to teach React to another set of developers. And they were not bad developers. They were already working with the web for some time. And it made me realize that the mental model that many people were working with just had little to no room for JavaScript in it, and they didn't consider web or the browser as a real platform to build applications. So that was the real motivation for me to prepare this. I know, I understand that it'll be kind of like preaching to the choir here in this crowd, but still. Let's start with how everything started. So, in 1993, there was Mosaic. It was the first popular graphical web browser. It was basically an application that could render HTML and navigate some hrefs. And that was pretty much all you could do with HTML at the time. So that was the hot web browser at the time. And in 1994, an offshoot of the original developers of Mosaic split off from there and started a new group to build a modern, better web browser. They called themselves the Mosaic Killers. They wanted to kill Mosaic and build a better web browser. And of course, they couldn't market themselves as the Mosaic Killers, so they called themselves Mozilla and built the browser Netscape. And Netscape was quite revolutionary at the time. It included cookies and frames and many other features that we take for granted now. And it was so significant that it took 3/4 of Mosaic's market share in just 4 months. And in 1995, they decided that the web was too static. They thought that the web could be more dynamic, and the browser should include a programming language, a simple language that the designers that were building HTML could write simple scripts in. And they were exploring many avenues for that, and they were considering including some of the popular languages at the time, like Scheme and TCL and Python and others. And they were also in talks with Sun Microsystems to include Java into Netscape itself. And in an attempt to facilitate their talks with Sun to include Java in the browser, they decided to build a small scripting language, JavaScript, which would act like a glue between HTML and Java. And of course, they didn't actually have the programming language JavaScript. So then they hired Brendan Ike, and he had to basically put together a demo in just 10 days to show Sun Microsystems. Anyway, and to this day, the name JavaScript is a registered trademark of Oracle. Anyway, and in 1996, this was after Windows 95 was released, and with it, Internet Explorer, and Internet Explorer was taking over most of the share of Netscape, and they were kind of like threatened that their work would just vanish with the when Internet Explorer and Microsoft took over the internet. And so they decided that the JavaScript, the language, should be standardized, and the specifications, the standard, should be open so anyone else could continue working on it and build their own implementations. So they went to European Computer Manufacturers Association to standardize the language. Standardizing a language is basically like looking at the code and writing down how everything works. And that specification, that document is open, and anyone can build their own implementation following that document. So ECMAScript was the standard, the language, and JavaScript was one of the implementation of that standard. So this standardization process continued in phases and took many years, 2 to 3 years to completely finish the standardization process. The first standard was released in 1997 or 8, I guess, and that was ECMAScript 1 and 2, and 3 was is the basis of JavaScript that we know today. Anyway, so we get to early 2000s after that. Early 2000s was the time the dot-com bubble had just bursted, and the internet was getting a lot of attention. It was becoming a more day-to-day household term, and developers were predicting awesome things for the internet. This is a quote from Zoltspolsky, who is the co-founder of Stack Overflow, and you can read the quote there. He wrote a blog called "How Microsoft Lost the API Battle." He's basically predicting that developers would no longer work with the Windows API and build native Windows applications because they could just build for the web and it would work everywhere. So that was the mindset of the time, and everyone were hopeful about the future. And by everyone, I mean, there were a lot of parties competing to become the platform that would become the platform for delivering internet-based applications. And it may look obvious to us now that it would be HTML and JavaScript, but it was not so obvious at the time. Mozilla was working on XUL. XUL is an XML-based markup language to build native applications, basically. It looks a lot like HTML, but instead of building divs and stuff, you could just write a button, and that button would look like a native button on Windows or Mac or whatever. This was actually a very it didn't really become the language for building web applications at the beginning, but it later found a new use case for building Firefox and Thunderbird extensions. Until Firefox 4 is supported, you could just point the browser to an XUL file and it would render a native-looking application. It worked with JavaScript and it was quite good. And Microsoft was also in the race. It was working on ActiveX and XAML and Silverlight. XML later became the foundation for WPF, which is the language that Windows 8 Metro apps and Windows 10 applications are built today. It was one of the hopefuls for becoming the language for web applications. And Macromedia was, of course, working on Flash with its own implementation of ECMAScript, ActionScript. It was quite, I guess, one of the more successful of these. And Oracle was working on Java Applets and Java Web Stars, so they were still trying to bring Java to the browser. And it was also still quite powerful. And I mean, even today, if we need to build something very powerful on the browser, we still need to look at working with Java or Flash still. So you might wonder what. So if these were the competitors, then where was HTML at the time? what was happening with HTML and JavaScript, and why weren't they in the race? So before we go into that, we need to understand how HTML and JavaScript was built, basically. We need to understand about two major organizations. W3C, World Wide Web Consortium, is a group of web browsers, basically, that control the standardization and specifications of HTML and all things browsing. And ECMA was, of course, the standardizing organization for JavaScript. So at that time, W3C, let's start with ECMAScript. ECMAScript 3 had been released. ECMAScript 3 was the standard that Netscape already had, and talks for ECMAScript 4 was happening. And ECMAScript 4, ES4 was going to be a radical new language. It would have classes and all of the other features that other major programming languages would have. And everyone were involved. Firefox and Mozilla were involved, and even Microsoft was involved in it. And but the problem was that all of these browsers were basically competing with each other at the time, and nobody really could work in a community and work together there. And there was a major conflict as to how much the language should be changed. And they were basically in a deadlock for a few years, and JavaScript was just didn't see any development at the time. And W3C was in a different problem at the time. They basically decided to abandon HTML and start working on XHTML, which would become a more stricter application of XML, which would become more restrictive and all that. And they were basically not even considering competing with the others. So this was the state of the HTML and JavaScript at the time, and others, Flash and everything, they were becoming more popular because there just wasn't any other options. So what happened after that in 2004 is a group of people from W3C committee, they decided to break off from there and start their own group, a new group. They called themselves WHAT-VG. It stands for Web Hypertext Application Technology Working Group. Basically, they thought that HTML itself should be developed and progressed to compete with other platforms, to become the de facto platform for building HTML, building web applications. What they were working on went on to become HTML5 and CSS3, and so HTML5 was accepted by W3C in 2007 after 3 years of conflict. And on the other hand, on the ECMAScript side, there was a meeting in Oslo in 2008 where Brendan Eich, the original developer of JavaScript, brought together everyone, all of the conflicting sides, and they basically decided what the web should not have, what JavaScript just should not have. And after those parts were removed, a compromise could be met. And of course, in 2008, much of the competition that was there in early 2000s had already settled, so it was more easier to come to a compromise. And the compromise was basically that many of the features that was envisioned for ECMAScript 4 would come to JavaScript, but in strides, in slower increments. And it would not change the language too much. It would just be a wrapper around the internal core language. So this agreement was called Harmony, and this led to ECMAScript 3.1 at the beginning, and which was later renamed into ECMAScript 5. This is the JavaScript that we know today, and is pretty much the standard. So by the late 2000s, JavaScript and HTML were both mature enough to compete with others, and they did compete and actually because they were the obvious choice for building applications. If just adding the functionality, it gave them a much better advantage over the others. So by the end of the 2000s, first decade, JavaScript and HTML were a viable platform for building applications. So let's look at how other platforms are evolving. So how does iOS as a platform evolve? How rapidly it evolve. And it's the same for all the platforms as well. What features Windows API will have is controlled solely by what Microsoft thinks needs to happen. It's the same for Android, or even Android, yes. But Web is different. So ECMAScript or W3C or any other community can make whatever specification they like to make, but the browsers are the ultimate deciders of what they are the implementations, and there's many implementations. So it's very difficult to dictate what APIs should be there and what features should be there in the browser. Also, the sheer variety of use cases that a developer can choose to make on web is so vast that it was very difficult to predict what APIs would work best for the web. And this came there were many other problems in the beginning, but the app cache issue in 2007 was this last straw. App cache was a feature that was introduced in HTML in 2007. It was basically a mechanism that allows us to build offline applications on the browser. It might be surprising to hear that there was such a feature in 2007, but the problem is that app cache was broken. The original design for app caches didn't consider many of the use cases that are common today, and one of them is that the developers couldn't decide. There was no ability to decide whether a certain page should be loaded from the cache or internet, and that just broke all of the dynamic web pages we had. Anyway, in around 2011, Facebook, along with others, were trying to build an offline version using app cache, and they found that it just couldn't be done. In 2011, they formed a group that was entirely focused on fixing app cache. It could be used to build an offline application. WhatVC separated out the committee to work on it and find a solution. And there was the conflict went on for almost a year. The original designers didn't think that the new use case should be introduced, should be added to the specification, and there was a lot of conflict. By the end of 2011, a fix was introduced in the specification that would allow for it, but the browsers had already lost any interest in implementing app cache, so it just didn't become a thing. Anyway, after this fiasco, some of the original group of people that were there in the beginning in the WhatVC and in the Harmony and everything, they came together in 2013 and wrote the Extensible Web Manifesto. It is basically a document that was to become the guiding principle for all of the work in specification and standardization of web was going to be based upon. And there's basically three principles there. One was that the browser should expose lower level APIs instead of building features. The example with app cache was that how app cache worked was completely a black box. It just exposed an interface to have some configuration, but the developers just didn't have any control in it, and which was the case for many of the other features as well. So the plan was that the browser would only expose lower level APIs, and the developers would be free to build whatever they want with it. The other principle was to explain existing features, which means that many of the other opaque features that the browser had would be opened up, and the lower level implementations would be open for the developers to work with. And the other principle, which is the most interesting, is that the specification would take a descriptive approach. Now, what this descriptive approach means is, look at how an English dictionary works. The dictionary does not create a word and tell people to use this word and use it this way. The dictionary is always lagging behind what the people are already using, what words people are already using. It's basically just documents what's already there. And the specification was to become something like that. After lower level APIs have been exposed, the developers could build anything they want, and this specification would lag behind and look at what the developers are doing and build features around that, instead of dictating how the web should work. So this was the guiding principle that started in 2013, and this is what's been driving the web and many of the exciting developments that has been happening in the web right now. For example, web components in Saturn is coming up. Is the new hot thing, but it's actually just explaining existing features. Web components in Saturn have been in the browser for a long time. It has just not been exposed to the developers. For example, if you look at a video tag, you can't really see it here, but still, the way we use a video tag is just write a video tag and give it a source, and it will just work. But where did that player controls come from? It's just the browser just gave it to us, and we just have to use it just like that. But now what we can do is open it up. We can see every div and every CSS that goes behind those player controls. This is part of explaining existing opaque features, and this goes beyond this. Like, there are other features that have been exposed like that. The other point, like exposing lower-level APIs. Cache API and fetch events have been a new thing. Like, this is the basis for service workers and stuff. So instead of building app cache, which would be a feature to build offline applications, the web now exposes the cache API itself. So the developers can decide what to cache and how to cache them. And it exposes the fetch API to intercepted HTTP requests and serve those requests from the cache or whatever. So this follows that principle of exposing lower level APIs. And another one of them is the notification API. The notification API is basically, it just allows us to display native notifications from the browser. But we use it with push notifications to display push notifications, but it does not dictate that we should always use it with push notifications. We can just show any notification at any time. So it exposed the lower level APIs, and we built the higher level implementation of it. The descriptive approach is what's driving a lot of what we are doing today. It allows for polyfills and transpilers, so the developers can always be ahead of the browser and decide where the web goes. The best example I like to use is the query selector. We've been using query selectors with jQuery for many years. jQuery came out in the late 2000s, 2009 or 10, and it had the query selector, the syntax. And it was standardized into the browser itself as query selector in 2013. So this is like this is an example from the past, but this is what's predicted to happen in the future. So like with React and other single-page application frameworks, we've been used to working with components and stuff. So now web components is going to have some of the same features that we've been used to with other components. So that's the descriptive approach that standardization and specification is taking. Anyway, and exposing lower-level APIs. This is from what Wave can do today. You can check out that application on your browser, and it's just search that there's just so little that the browser is yet to open up, and everything is already there. Like there's only some of it, like NFC and ambient light and all of that, but so many of the features that we use from native APIs is already there on the web, and this is where the web is heading. Web has finally become what the pioneers in early 2000s were predicting it to become. Web is now the platform to build applications. Thank you.